Good morning, Cappuccino. It's been a week. I hope you are ready for some math and remember how to do some things. So let's start off with our warm-up. So today is Tuesday, April 14th. And first we're going to look at some problems with fractions. So we're going to multiply some fractions. We're going to divide some fractions. Do some more multiplication of fractions with whole numbers. And then let's solve this equation. So if you want, go ahead and pause the video and try them yourself first. And then I'm going to do them also. Okay. So here we go. Problem number 1, 1A. 1/5 times 2/3. When we multiply fractions, we just need to multiply the numerators, 1 times 2, and multiply the denominators, 5 times 3. Let's see, can I reduce? Is there a same number on top as on the bottom? No, nothing I can reduce, so we'll go ahead and multiply. 1 times 2 is 2, 5 times 3 is 15. So there's the answer to letter A. Okay, letter B, 1/5 times 10/11. Again, I'm going to multiply the numerators, 1 times 10, and on the denominator, 5 times 11. Now, I'm thinking, wait a minute, I can rewrite 10. I can rewrite that. 1 times 10 is 10. 10 is the same as 2 times 5. So I could do this. I could say, okay, 10 over 5 times 11. But I'm going to rewrite that 10. 10 is the same as 5 times 2 over 5 times 11. And now I can reduce it. So 5 divided by 5 is 1. So my answer is just 2 over 11. So don't forget to reduce fractions when you can. All right, the next one, letter C, is division. So when I divide, remember we're going to rewrite this as multiplication. So I'm going to keep the first fraction, 1 over 5, 1/5. I'm going to change division to multiplication, but then I need the reciprocal of the second fraction, 3 over 2. And now it's just like the first two problems. 1 times 3 in the numerator and 5 times 2 in the denominator. I get 3 over 10. There's nothing I can reduce. And for letter D, 1/5 divided by 10/11. Again, I'm going to rewrite it. Oh, I forgot to box my answer. Let's box my answer. I'm going to rewrite it. 1/5, change it to multiply, and take the reciprocal of the second fraction. So I'm switching. The 10 is going to the bottom, and the 11 is going to the top, to the numerator. So I'm going to have 1 times 11 over 5 times 10. I don't think I'm going to be able to reduce this one. 1 times 11 is 11. 5 times 10 is 50. I can't break up the 10 into two numbers, so I can't reduce that one. Okay, letter E. We have 2/3 times 9. So remember how we do this? We can just do 2 times 9 over 3, or we can switch the 3 over here. We can do 2 times 9 over 3. Hey, I actually like doing that one because I know what 9 divided by 3 is. That's just 3. So I still have my 2. 9 divided by 3 is 3, which gives me 6. Okay, so remember the Alex and Morgan ways? This was the Alex way. This is the Morgan way. I could have kept going this way. 2 times 9 is 18. And then 18 divided by 3 is 6. It just takes a little bit longer. All right, let's try the next one, letter F. So I have 12 times 5 over 6. Okay, I can do it the Alex way, which is 12 times 5 all over 6. Or I can do it the Morgan way, which would be 12, move the 6 underneath the 12, then times 5. Ooh, I like that, because I know what 12 divided by 6 is. 12 divided by 6 is 2. And 2 times 5 is 10. Because 5 times 12, oh man, that's a big number. That actually happens to be 60, so I could have done it this way. 60 divided by 6, and 60 divided by 6 is also 10. Okay, so remember the Alex and Morgan ways? We could do that. All right, last one. Let's solve. 5x plus 2 equals 2x minus 7. All right, I've got this problem. I've got x's on both sides of the equation. I don't like that. So I'm going to get rid of the one on the left. To get rid of a positive 2x, I'm going to minus 2x. So minus 2x minus 2x from both sides of the equation. If I do something to one side, I have to do the same thing to the other side. 5x minus 2x is 3x. I still have my plus 2. 2x minus 2x just goes away. That's 0. And I'm left with a minus 7, or a negative 7. All right, so from here we have a choice now. We can continue balancing, or you can deconstruct. Either way is fine with me. I'm going to let you go ahead and take it from here, and I want to see what's your answer, okay? So you solve this. I'm not going to do it for you. You can use balance method or deconstruct, okay? So go ahead, deconstruct or use the balance method. Okay, I'm going to leave that up to you. Okay, so now what are we going to do new today? Today we are going to talk about how is math used in the real world. Well, what's happening in the real world right now is we are all staying home because of the coronavirus, COVID-19. So I want to show you a graph of COVID-19 cases in San Mateo. And notice, if you can see it, zoom in, notice that this is March 15th. March 15th, that was the weekend we stopped going to school. Our last day of school was right here. That was March 13th. It was right there. And this is how many corona cases there were in San Mateo County on the last couple of days that we were in school. So notice I have out here April 12th. That was this weekend. So how many corona cases are there now in San Mateo County? So if I look at my scale here, it's kind of hard to see. It says this is 200 and this is 0. So this would be 100. And so it looks like, I wish I had my glasses on. What did I do with my glasses? There they are. Let's get some glasses. It looks like this would be about 50. So it looks like there were about 50 cases of the coronavirus when we left. Okay, this would be about 50. There were probably about 50 cases of coronavirus when we left school. So how many coronaviruses should there be now? So what we can do is we can take a ruler and we can extend the line all the way across the paper. So I'm going to extend the line. I'm going to use my ruler to go out here. So if I do this, so starting at back when there was only like 0 or 1, then I can extend the line all the way across the graph. So how many corona cases do I think there are now? Well, April 12th looks like, if I bring that straight across, it would be better if there was graph paper on here. It looks like there's less than 200. So this is called a linear model, okay, or a linear relationship. because I drew a line. Okay, so this is a linear relationship because I drew a line to sort of connect my data points and to extend it so that I could guess how many do we think are about out here. And it looks like maybe 180, maybe 180 corona cases if it keeps growing at the same rate. If it keeps growing at the same rate, we could say there's 180 corona cases. So that's if it's a linear relationship. So how do we predict exactly how many people there are? What we do is we write an equation. We write an equation like that we can solve, an equation, something somewhat like this, that we can solve to figure out how many people have the coronavirus, or how many people we think will have the coronavirus. Okay, so we're going to learn all about linear relationships. Well, I want to give you a little peek at, I have the actual data for the number of COVID cases in San Mateo County, and it actually is not linear. Notice it actually looks like this. This is not linear. This is not linear. Because I can't draw a straight line. I can't take a ruler and have it go up that high. So notice this is curving. My line is changing. It's curving. So when you have this curve, you might have heard in the news, they talk about it being exponential. So see this curve right here that I just drew with my red pen? We call this curve, this is exponential. And hopefully we'll have time to learn about those this year. If not, you'll learn about that the next time you take algebra. I'm misspelling it. Exponential. This is an exponential growth. Exponential growth. It's not linear. So linear would be, I could just draw a straight line and I could predict how many corona cases there would be. But in this case of COVID-19, it's actually not linear, it's exponential. So we're going to get to those eventually, but we're going to start by starting it out simple with talking about linear relationships, where I can predict what's going to happen just by drawing a straight line. Okay, but before we can get to drawing the lines and writing equations for the lines, we need to do some basic work. So back to our notebook, and we're going to go to our notes. So back to our notes, and we need to take some notes on something called the coordinate plane. So it's going to be helpful if you have a ruler. So you're going to want to get a ruler. If you don't have a ruler, go find one right now. Get yourself a ruler, or you can just use something like here I have an envelope. You can use an envelope to help you make straight lines. It doesn't have to be a ruler. You just need something to help you draw straight lines. Okay, so what we're going to do is we are going to take notes on the coordinate plane. Notes. Here's our notes. Taking notes. And we are going to talk about the coordinate plane. What is the coordinate plane? Coordinate plane is we start by drawing a number line. So I'm going to draw a number line. And I'm going to put 0 in the middle. So here's going to be my 0. I'm not going to label it. I'm just going to say that's 0. And then this way would be 1, 2, 3, 4, 5, etc. And then to the other side of 0, this would be -1, -2, -3, -4, -5. Okay, ooh, I just got it all smeary. Ooh, that's bad. And I could keep going, so I can put little arrows on there. I could keep going. Now, why did I not put 0 there? Because to make a coordinate plane, we're going to put another number line going right through the 0. So I'm going to go this way. Now, this is another number line. I just took this number line and I basically rotated it up. So this is 0 again. This is 0. So if I count, this is 1, 2, 3, 4, 5. But I could also count down. If I count down, it's like going to the left. This would be -1, -2, -3, -4, -5. This is called the coordinate plane. Now, the coordinate plane that I showed you on here, it's like, well, that doesn't look like what I showed you. The coordinate plane here, if I take my pencil, is going like this. I can make a coordinate plane on here by going like this. And see how this is March 15th? So it would be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, and then we'd have -1, -2, -3, -4, -5, etc. going that way. And then here's my positives, 50, 100, 150, 200. I could go -50, -100, -150, -200. So I could change this graph into a coordinate plane, okay, by just extending the lines. So that's how this relates to this, because we can have negative numbers in algebra. Okay, so what do we do with a coordinate plane? We put points on the coordinate plane. We've put points on a number line before. We can put points on a coordinate plane. And when we put them on, we write what's called a coordinate pair. So coordinate pair looks like this. I'm going to give you an example, and then I'll explain the example. So my example of a coordinate plane is I put a parenthesis, and coordinate pair. I put parentheses, 3, 1, and this is going to be a point. This is going to be 1 point on the graph. And so where is this point? I start at 0, so I'm going to start at 0. The first number tells me to move either to the right or the left. Since this is positive, it means go to the right. Okay, so I'm going to go to the right 3 spaces, 1, 2, 3. And then the second number tells me how far up or down to go. Since this is positive, it means go up. So I'm right here. I went 1, 2, 3 to the right, and then the second number tells me to go 1 up. So this is 1 point, and here it is, and I can label it. This is 3, 1. It is 1 single point. So before, when we had a number line, before, we would just have like 0, 1, 2, 3, 1, 2, 3, and we would put a point on 3 like that. That would be that. But now that I have the second number, I then need to move either up or down. Okay, so there's my point 3, 1. So the first number, we call it x. We call the first number x. So when you have a coordinate pair, the first number is called the x coordinate, and the second number is called the y coordinate. So the x coordinate and the y coordinate. The x coordinate is always either left or right, depending on if it's positive or negative, and the second number is the y coordinate. It's always either up or down, depending on whether it's positive or negative. So because left or right is called the x coordinate, this line, we call it the x-axis. So I'm going to label that as x. And then the second number is up and down, so this line is up and down, so we call this the y-axis. Okay? So the lines are called see, where should I put this? Put it down here. Okay, the lines are called the x-axis and the y-axis. Okay, so this is the y-axis, this is the x-axis. Okay, and this is the x-coordinate, and the second number is the y-coordinate. Okay, x-coordinate, y-coordinate. All right, let's do another example. So we've got -2 and 4. What if I want to put on -2 and 4? Where would this point be? Okay, so the first number either goes left or right. Since it's negative, it's going to go left. And the second number goes up or down. Since it's positive, it's going to go up. So I always start in the middle. This is 0, 0. I start at 0, 0. I'm going to go 2 to the left, 1, 2, and then up 4. 1, 2, 3, 4. And there's my point. So that point is this. This is 1 point. So I can label that -2, 4. Okay, one more piece of information we need before we start working in MathSpace. Last piece of information is, notice I have broken up my paper into 4 sections. See, these lines have created 4 sections. We call these quadrants. So we're going to label them with their number. This quadrant right here, that's where most graphs in the real world, you find most graphs in this quadrant, this part of the graph. Notice on my COVID-19 graph, all my data was in this part of the graph. This is called the first quadrant. And in English, we use a Q for quad, not a C. Quadrant. First quadrant. And then we label them going counterclockwise, like backwards on a clock. This would be the second quadrant. So hopefully you can guess this one. This would be the third quadrant. And finally, the fourth quadrant. Okay, so those are our notes. You want to keep your notes handy as you go to MathSpace. Okay, so now you're going to go do MathSpace, and in MathSpace, it's number 18. So you're going to do number 18 in MathSpace. That is the new assignment, so I want everybody to find number 18 in MathSpace. Now I printed out what the questions look like in MathSpace. So the first problems are going to look like this, and I'm sorry it's so small. It's very small. Let's zoom in on this. It says, what are the coordinates of the point shown in the number plane? Okay, number plane, that's another word for coordinate. Coordinate plane. That's the same thing. It's a coordinate plane. This is my coordinate plane. Give the coordinates in the form x, y. So this point right here, how did it get there? How far to the left did they go, and then how far up did they go? So it looks like it's -1 1/2. So they went -1 1/2. So the x value is -1, and I can write 1/2 as 0.5. -1.5. And then how far up did they go? 1, 2. See, watch for the scale. They went up 1, 2. So those are the coordinates of that point. So then I would enter that here. So -1.5, 2. Okay? Most of the problems are not this hard. They don't have decimals. There's only one answer that has a decimal answer. The rest are a bit easier than this one. Okay, there's a second type of question, and it looks like this. It says, consider the point -1, -5, plot the point on the number plane. And they give you the point right here. You've got to grab it with your cursor on the computer. You got to grab it and drag it. So I'm going to drag it -1. Remember, the first number is either left or right, so that's negative. It's going to be to the left. The second number is either up or down. Since it's negative, it's going to be down. So I'm going to take this point, I'm going to drag it to the left 1, and then I'm going to drag it down 5. 1, 2, 3, 4, 5. And that's where I'm going to leave it. It's going to end up here, so that it's not going to be there anymore. It's going to be right here. This is the point, -1, -5. Okay? Then it's going to have a question B. It's going to say, in which quadrant is that point? Which quadrant is that? So I'm going to look at my notes, and I'm going to say, okay, that quadrant is this one right here. Oops, can't see it. That's this one right here. So it's in the third quadrant. So I'm going to look at my notes. I'm going to compare it to my notes. There we go. This is this quadrant. So it's the third quadrant. So on the math space, it's going to give me a choice. Which one is it? Here it is. It's the third quadrant for this point. All right. There you go. Good luck. If you need help, you can call or text Mr. Alvarez, or you can email me, and we will be in touch real soon to let you know when we will have our first Zoom meeting. I can't wait to hear you and see you on Zoom. So watch for an email letting you know when we're going to have our first Zoom meeting. And welcome back from spring break. Take care. Bye-bye.